Welcome to the video lecture series of Grade 10 Physics. Today I will discuss the lesson electricity and our topic is electric power. So what is electric power? Electric power is nothing but the work done per unit time. So how much work is doing in a particular time, that we are referring as electric power. So power is the electrical work done per unit time. So P has the expression P is equal to W by T. W is the work done and T is the time. And its SI unit is watt. W. It is represented as W. Okay. So power is the electrical work done per unit time. Now we can just see what are the other formulas for calculating power. So P is equal to W by T. That expression now we wrote. P equals W by T. Power is the work done per unit time. Now, what is W? W we have calculated previously as W is the V, potential difference into charge. W is equal to V into Q. Now, when we substitute W in our power equation, the expression becomes, we are writing W as V into Q. So, V into Q by T. What is Q? How can we relate Q with the current I? Q is equal to current into time, I into T. So when you substitute Q in the expression with the I into T, so V into I into T divided by T, which means we can cancel T, you will get VI. So therefore power is equal to, we have the expression now, P is equal to VI. This is the second expression for power. First expression is P is equal to W by T. This is equation 1. This is equation 2. If work done is given, you can use the first expression for calculating power. If potential difference and current is given, you need to use second equation. Now we can see some more relation for calculating power. Okay. So P equals V into I. We substitute Ohm's law over here. According to Ohm's law, V, what is V? As per Ohm's law, V is equal to I into R. This is per Ohm's law. Okay. So P we have V into I. So V we are going to substitute with Ohm's law. So what is the expression now? IR into I, which is equal to I square R. So this is the third expression to calculate power. P is equal to I square R. Okay. Now we can write one more relation in terms of V and R. So P, I am taking the normal expression P is equal to VI. From this, what is I? I is equal to, according to Ohm's law, I is equal to V by R. This is per Ohm's law. I equals V by R. So therefore P equals V into V by R, which means V square by R. So we got the power, the last equation as V square by R. So these are the four expressions commonly used in numericals for calculating power. The first one is P equals W by T, first expression. Second expression, P equals VI, second one. And third one, P equals I square into R. Fourth one, P equals V square by R. Now we can solve some numericals based on these equations. The first one is, an electric bulb is connected to a 220-volt generator. The current is 0.50 ampere. What is the power of the bulb? It's a direct question. An electric bulb is connected to 220-volt generator, which means potential difference is given. Potential difference V is equal to 220 volt, and the current passing through the generator is 0.50 ampere, which means I is equal to 0.50 ampere. What is the power of the bulb? Which expression we have to use? Potential difference and current is given. Therefore, P is equal to VI. V equals 220 volt and I is given as 0.50 ampere. When you solve this, you will get 110 watt. Power is equal to power expressing in terms of watt. So you can write the unit as W. 110 watt. Now, second numerical we are going to calculate is, an electric heater of its power 1000 watt has a resistance of 10 ohms. Okay, the device used here is electric heater. It has a power of 1000 watt and resistance 10 ohms. Calculate the magnitude of the current. So we have to calculate the current value. How much current is used by this electric heater, and its power is given is 1000 watt. So P is equal to 1000 watt and the resistance is 10 ohms. So what is the current passing through this electric heater? So power and resistance is given. We have to use an expression which relates I, P and R. So which expression we should use over here? We have related 2-3 expressions for power. Okay, so the expression we use here, P is equal to I square R. This expression we have derived from the power expression by relating with the Ohm's law. What is P? P is equal to I square R. So I square R is equal to P. Then therefore I square is equal to P divided by R. From this we can calculate our I. So I square is equal to P by R, which means 1000 watt divided by 10 ohms. So you will get 100 ampere. This is for I square. So what is I? I is equal to root of 100. That's equal to 10 ampere. Fine. Now let us take the third numerical. The question is, electric heater is rated. Again the heater, it is rated 1000 watt and 220 volt. It means power. This is power and 220 volt is the potential difference. So P is given 1000 watt and V is equal to 220 volt. Calculate the resistance of the heating element. Okay. So P and V is given. We have to use the resistance equation. What is the resistance equation? So we already derived an expression for P by using Ohm's law. P is equal to V square by R. Okay. So here V is given, P is given, R we have to calculate. So P into R, when you cross multiply, you will get P into R is equal to V square. Therefore, R is equal to V square by P. Okay. So R, resistance of the heating element, R is equal to V square divided by P. What is V square? V is 220. So 220 volt into 220 volt divided by P. P is 1000 watt. Okay. This is very easy expression for solving because the denominator we have 1000. So you will get value very easily. Only you need to multiply 22 into 22. You can cancel the zeros. Okay. So 22 into 22, it will be 484 divided by 10. It means 48.4 ohms. So resistance we have calculated as 48.4 ohms. Thank you, children.